All right, so the last section of notes here is actually kind of a big section of notes, but it deals with water, acids, bases, and pH. So we're going to start off by taking a look at water. Water is the most abundant compound that we have in living things, and we have to understand water in order to understand the functions of living things, because since water is so present in cells or any living organism, it really affects what they can do and how it acts. Excuse me. Water is composed of 2 hydrogen atoms and 1 oxygen atom that are joined through a covalent bond. And if you remember from physical science, this is where they share electrons. And this sharing and the way that these electrons are shared actually creates some unique properties of water. Now, in your notes, we don't call these properties. We actually call these structural characteristics. And then we're going to get into the properties. The structural characteristics are things that we can't see, but we know that exist because of how water behaves. In other words, its properties. So the first structural characteristic is polarity. Polarity happens because the oxygen atom has a greater attraction for the electrons than the hydrogen atom, and this creates a magnet-like polarity. So down in the space below there, we're actually going to draw a water molecule. So water molecule is made up of one atom of oxygen and 2 atoms of hydrogen. Okay, so it kind of looks like an upside down Mickey Mouse head. What happens is the electrons that they are sharing, and those are right here, kind of where they are connected, those electrons there spend more time with the oxygen atom than they do with the hydrogen atom. So what happens is we end up with this partial negative charge. Okay, so the little almost music note looking thing means that it's partial on the oxygen end, and that we end up with a partial positive charge on the hydrogen end. It's not a full positive and it's not a full negative because the electrons aren't completely taken away from one or the other. Now, the other structural characteristic that we have is hydrogen bonding. And this happens because of the polarity. Once we have that magnet-like polarity, it actually attracts water molecules to each other. And we're going to sketch that out in a minute here, but both of these are responsible for water's special properties that we can see. So let's take a look here at this hydrogen bonding, and you want to draw this in the space in your notes. So again, we have our water molecule here. No, sorry, my thing is not behaving. There we go. I have my water molecule. All right, let's try this again. I don't know why it's being lazy. No. Okay. And we know that this end is our negative, and this end is our positive. So let's draw. Being very slow today to respond. We're actually going to draw 4 more water molecules. Now, this hydrogen bonding is a pulling force between the water molecules. So we know that opposites attract. So this end here is a partial positive, and it gets attracted to the partial negative on the oxygen. Same thing here on this one. Now down below, these 2 oxygens are partially negative. So we have a negative and a positive that attract, and same thing over here. This is a pulling force that we call the hydrogen bond. not anything that we can see. But what you can see here is that each water molecule is capable of pulling on 4 additional water molecules. And so it actually allows them to really pull on each other very, very tightly. Here's another way of looking at it, just in a little bit different type of arrangement. This is like a 3-dimensional type of arrangement. Okay, so again, we have these hydrogen bonds. Their little music note things, or the deltas as they're called, look a little bit different than mine, but that's okay. All right, so let's take a look at the properties of water. Now, you're going to actually take off that bullet point that says hydrogen bonding pulls water together and creates blank. Just cross that off. We don't need that in our notes. Okay, so our first property of water is cohesion. Cohesion is attraction between molecules of the same substance. So this would be water molecules to water molecules in this case. What you have to understand is water is extremely cohesive. It allows bugs to walk on water and creates things like surface tension. It's also what allows water to create droplets, whether it's something like this when it's falling from the sky, or if you have a surface and it beads up, okay, that is cohesion because the water is actually sticking to itself. If it didn't do that, then it wouldn't behave in that manner. The second property of water is adhesion, and this one is kind of an opposite. It is the attraction between molecules of a different substance. This is what makes water stick to the sides of the container, like in a measuring cup or a graduated cylinder. So if you think of a graduated cylinder, okay, the water level looks like this, and we have to read it at the bottom because it creates the meniscus. If you think about any of your foods classes, you also have the same thing with like a liquid measuring cup. That's why you have to set it on the counter and actually read it from the bottom, because that happens. It also makes water rise in a narrow tube, and we refer to this as capillary action. This is very important in plants because this is how water gets from the roots to the leaves in a plant. Okay, trees don't have pumps in their bodies like humans do. We have a pump. It's called our heart. So in order to circulate things, they actually have to be able to pull it up versus gravity. And so they're able to do that using the capillary action. Water also has a high specific heat. This is the specific heat is the amount of energy needed to increase the temperature. And it takes a lot in order to raise the temperature of water. So what we have to remember is in order for the temperature to increase, the molecules have to move faster. But what's happening is because of the hydrogen bonding, it makes it hard. So you have to add a lot more energy to do it, to make it move faster or make it move slower. And this actually does have major effects on things like our weather. Areas near the water stay cooler in the summer because the water takes longer to heat up, and warmer in the winter because the water holds lots of heat. So, in the next month or so here, here in October and November and even into December, if you watch the temperatures here in Harrisburg, we're not near a large body of water. We'll have temperatures, in the 60s, 50s, and into the 40s. But if you go over to the coast, it's going to be a lot warmer. It'll be in the 70s, 80s, and 60s compared to what we have. And that's because they've got that huge body of water right next to them, the Atlantic Ocean, that takes a long time to cool down. On the other side of things, though, in the spring, when we start warming up, they're going to be a lot cooler than we are because it takes a longer time for that water to heat up. Water also has a density anomaly. Anomaly means abnormality. Basically what it means is water is more dense as a liquid than a solid. And this is what allows ice, that's a solid, to float on the surfaces of lakes and rivers. So as that ice forms, it gives the life that is underneath it still room to live. So things like the fish and the plants and all of those aquatic life things can actually survive in the liquid water below the surface. If water didn't have this density anomaly, that wouldn't happen. So if this didn't happen, then all of the aquatic life would die each winter as the bodies of water freezes. The next and last characteristic of water is that water is a universal solvent. Basically what that means is water is able to dissolve a lot of compounds. Now, why is this necessary? Because a lot of the chemical reactions that we have in our bodies have to take place in dissolve or in a dissolved form in order to take place. This is what drives our metabolism. If things weren't able to dissolve in water, which is what we are mostly made up of, then these reactions wouldn't actually take place. And so that ends our section here of notes on water, and then this next section of notes will talk about things like acids, bases, and pH.